You know that feeling, right? You ask an AI a really tough question, maybe about a super long document or some complicated code, and then you just wait. You're just staring at that little spinning icon, and you can almost hear the gears turning in the background. Well, that feeling, that waiting, it gets right to the heart of a massive challenge for AI today.
See, we're all kind of stuck in this AI waiting game. On the one hand, we want these models to be incredibly smart, to give us these perfectly accurate, detailed answers, but getting that kind of brainpower costs a lot. We're talking time and money. It's this fundamental trade-off that's kind of holding back the AI we use every single day.
So that leads us to the big question we're tackling here. Why does it actually take so long for an AI to think? What's really going on behind the scenes during that long pause before your answer finally pops up?
And here's the problem in a nutshell. If you want more thinking, which researchers call scaling test time compute, you get higher accuracy. That's great. The model can check its work, explore a few options, and give you a better answer. But the flip side is a huge spike in cost, both in how long you have to wait and the actual dollars and cents it costs to run the thing.
To really get why, we need to look at how these models work right now. The standard way of doing things is basically thinking on the spot.
Okay, picture this. Imagine someone hands you a massive textbook and the final exam at the exact same time. And for every single question, you have to frantically flip through the entire book from page 1, find the right info, and then try to put an answer together. It's just wildly inefficient, right? Well, that's pretty much what most AIs are doing right now.
The technical name for this is test time compute, and it means exactly what it sounds like. All the heavy lifting, all the real reasoning happens after you hit send on your question. The model gets the context like a PDF or a bunch of code and your question all at once, and it has to figure it all out from a cold start every single time, all while you're on the clock, just waiting.
So if you look at the standard approach, that raw context gets fed directly into the test time phase. It doesn't matter if you ask one question or 10 questions. The model has to do all that expensive, redundant work over and over and over again. It never actually learns from what it just did.
Now that is clearly not the smartest way to work, but what if there was a better way? What if the AI could actually prepare ahead of time? What if it could harness the power of pre-thinking?
So let's go back to our student. Instead of that frantic cramming during the test, what if the student got to study the textbook before the exam even started? They could read through it, highlight key stuff, maybe even make some notes. Now that would be a game changer.
And this brings us to the big idea from the research, sleep time compute. This is all the thinking the AI does offline on a piece of context before you even ask it a single question. So when the AI would normally just be idle, it's actually using that downtime productively, pre-calculating useful info, and basically anticipating what you're going to need later.
And now, look at this new approach. It's totally different. The raw context first goes through sleep time. This is where the AI creates a learned context, which is basically its study notes. So now when your questions come in at test time, the model just has to consult its notes. The hard work is already done, which makes getting the final answer incredibly fast.
Okay, so this all sounds great in theory, but does it actually work in practice? Well, the researchers ran the numbers, and the results are, frankly, seriously impressive.
First up, efficiency. With sleep time compute, an AI can get you the same quality answer with about 5 times less work at test time. That is a massive reduction in the computer power needed while you're sitting there waiting. And it's not just about going faster, it's about being smarter. By letting the AI do more pre-thinking, the researchers saw accuracy on really difficult problems jump by as much as 18%. The more the AI studies, the better its grades get.
And this is where it gets really practical. What if you ask multiple questions about the same document? Well, by front-loading all that thinking, the average cost for each question can drop by 2.5 times. That first study session just keeps paying off again and again.
This idea is called amortization, and you can see it right here. That first question, yeah, it has a pretty high cost because it includes that initial study session. But look what happens. As you ask more and more questions, the average cost just plummets. You're spreading that one-time workload across a bunch of queries, making each one way, way cheaper.
So what does this all mean? What does this super elegant solution mean for the AI tools that we're all using every single day? What's the future of AI thinking look like?
Well, the real-world impact could be huge. Just imagine a coding assistant that has already studied your entire code base before you ask it to fix a single bug. Or a Q&A system that has already read and summarized a 100-page report before you even think of your first question.
We're talking faster chatbots, smarter document analysis, just much quicker, more affordable AI help all around. But what's happening on a deeper level is just so cool. The researchers call it representation learning. The AI isn't just pre-calculating answers. It's actually learning to create its own, more efficient summary of the information. It's essentially writing its own study guide in natural language to make itself a better problem solver.
So this really simple-sounding idea, just letting AIs sleep on it, it doesn't just make them faster. It fundamentally changes how they work, taking them from frantic last-minute cramming to thoughtful, deep preparation. And it really makes you wonder, if we give our AIs the time to think when they'd otherwise be doing nothing, what on earth will they dream up next?